Now, a big question arises that whether these statements and this theory is actually correct. Is our space that mysterious? And let me tell you, our space is a lot more mysterious than this. But this was an uprising question of that generation, so Sir Einstein came up with multiple explanations for this answer, and we can say it as proofs of general relativity. So the first was an explanation that has to do with the motion of Mercury. According to Newtonian mechanics, the planet should just trace the same orbit across years. But that wasn't happening. Okay, observations show the orbit of Mercury is just shifting with time. So, what was the reason? Why is Mercury acting so weird and strange? Yeah, why is it acting so strange? None was able to give a good explanation for that at that point. But then Sir Einstein came up with a very nice idea, and he came up with this general theory of relativity that explains about this. So, using the equations of general relativity, he was able to spot and predict the precession of perihelion of Mercury. I know it's really a big deal. So he made a prediction that had to do with the bending of light. I know that's because light is always thought as like rectilinear. It's just always traveling in straight line, but it's science and anything can happen. So what he said that if you have a distant star sending light towards Earth, it's simple. But if you're on the other side of sun and now you see the star, what's gonna happen? I know that's a very fair, easy question. According to Einstein's new theory, it's going into a curved trajectory as it goes to the curved environment around the sun, you know. So that affects the position of star is sky shaped. And just for extra knowledge, for Mercury, the perihelion rate due to general relativistic effect is 43 arc seconds per century. Yeah. Einstein was able to explain this and just prove it mathematically. But after some years, a team of astronomers went out and measured the angle between the two positions, taking photographic plays during solar eclipse. So they compared the position of a distant star taken 6 months earlier and now. So the surprisingly, the data seems to be very much accurate, and it showed that Einstein's ideas were actually very correct. Some months after, when Einstein published his papers on general relativity, a German astrophysicist Carl Schwarzschild found it. He found the first exact solution to the Einstein field equation of general relativity applicable and in otherwise empty space. So it's a simple case of a perfectly spherical object that is embedded in otherwise an empty space. Okay, now what does that mean? You must be thinking that Aryan, in just last 2 seconds, you came up with totally new terms and we haven't learned about that by the course of now. And where did that Einstein field equations and that empty space came from? Einstein field equation is actually general relativity. Now you must be thinking that why you haven't told us that by now. So let me tell you. When like with an example, let's do it. So whenever you're making a website, you first learn about front end. Front end is where a user come and access your website, and it's what is shown to people that just beautiful thing and cherry or all. Okay, that that content that is shown to your people is what is front end. In our case, front end is general relativity. I've told you about that, and all the things that I've told you by now, this theory and everything, that comes in actually front end. Now there is a back end. Back end of a website is where the database is stored about the users that is accessing your website is stored there. So now in here the Einstein field equation is what is back end. It's a lot complex to explain, but I'm gonna explain in this the head part of this series. So this is going to be a really great job we're going to do, and it's going to be a little complex, but I'm gonna make it simple, and I'm gonna explain it mathematically, so you don't need to worry. Now coming to empty space. Empty space is a relatively empty space that there's something like is far from reach of atmosphere of celestial bodies, like I'm not talking about atmosphere of Earth, not that. Atmosphere of celestial bodies, like atmosphere of stars and planets. So it's far from reach of there. It's just an empty thing, and there's nothing. So we can say that there is nothing to be in reference from, no reference frame. That's what I actually meant. So, what that whole line meant that I spoke 2 months back, that even if you take away the stars and everything, there's still something in universe that is pulling gravitationally. What is there so mysterious that it is pulling? Even if we remove every star or planet that is actually creating, um, what we can say, gravitational pulps, it's warping. There's nothing there's nothing planet or star, but it's still being pulled gravitationally. But people neither took general relativity or spatial ideas seriously. So it's definite, if someone came after around 1000 or 2000 years after with a mindset of people being thinking like that light is actually rectilinear, and rectilinear means actually it just following a straight path. So now thinking that, and just suddenly a man came and said, hey guys, like an actual event. That sound is actually so weird, and it's actually just so inappropriate, I know. But then there was a turnover. There was something big coming, and that was actually going to start the new era of physics. Now we know that Einstein was a big deal for physics, because the basic ideas before Einstein just broke that all ideas that before them, just break into pieces and grind them all. Now he came up with his own physics, and that's we're gonna discuss ahead. So if you have liked this video, please like and share, and please subscribe to my channel. That would be supportive for me, and I'm gonna come with more videos like this. So see you in the next part. For that, by that time, bye, and just keep learning and be healthy.